Symmetries of sister algebras. I would like our joint work with Professor Jan Hamhalter from Czech Technical University in Prague. There are many phases of sister algebras whose symmetries encode important aspects of a structure. We show that in different situations, where the symmetry are implemented by Jordan star isomorphism and lead to full Jordan invariants. In this respect, we study the following structure: one-dimensional projection on a Hilbert space with transition probability and orthogonality relation, projection lattice of phonoidal algebras and A-star algebras, it is die-type theorem, and abelian sister subalgebras with set theoretic conclusion. It is a verification program in quantum theory. It is basic notation, sister algebra, orthoisomorphism, set of projection, phonoidal algebra, and A-star algebra. And star homomorphism, it is a linear map from sister algebra A to sister algebra B, presents star operation. And star homomorphism that reverse the product, it is star anti-homomorphism, and Jordan star homomorphism preserves the square and star operation. And first steps for our interest, it is this proposition. Let A be a star sister algebra that is closed linear span of its projection, and be another sister algebra. When a bounded linear map psi from A to B is a Jordan star homomorphism, if and only if it is present, it preserves projections. Sorry. First steps, it is Gleason theorem. We have finitely additive x-valued measure on P of A, on set of projection, if map mu satisfied additivity whenever P and Q are orthogonal projection. And we will have classical measure on P of A if X is complex value sets. Gleason type theorem, it is a series of deep results that originate by Gleason theorem and culminate in early 19th of Barnes and Wright theorem. Classical Gleason theorem, it is with theorem. Let mu be a finitely additive bounded measure on sets of projection of B of H, where H is a Hilbert space of dimensional not equal to. When there is a bounded linear functional f on B of H, extended mu. The preview theorem has not trivial extension to nearly all von Neumann algebra. Let us recall that von Neumann algebra has type 1-2 direct sum, and if it is, has a direct sum and star isomorphic to the algebra of all continuum function on a Hyperstone space X with value in the algebra of 2x2 matrices. And Gleason-Barnes-Wright theorem and this theorem, let M be a von Neumann algebra not having type 1-2 direct summand, and X be a Banach space. And when a bounded finitely additive measure mu on P of M to X and extend to a bounded linear map T from von Neumann algebra M to X. And for sister algebra A and B, psi from A to B is called quasi-Jordan style homomorphism if it homogeneous additivity for elements A and B commute, and psi for in this Jordan star homomorphism. And when psi is bijection such that psi and inverse psi are quasi-Jordan star homomorphism, we call psi quasi-Jordan star isomorphism. It is a sequences. It is a consensus on theorem Gleason-Bansride that any quasi-Jordan star homomorphism defined on phenomenal algebra without type 1-2, the direct summand is linear. This does not hold for type 1-2 von Neumann algebras. Next line with our investigation, it is Wigner type theorem. We have a set of all projection acting on Hilbert space H and set of finite rank operation in H. And in probability structure and quantum mechanics, projection pxi corresponds to the state on the system. Transition probability between two states is when given by this equal. Wigner theorem, its original form is concerned with symmetries preserving transition probability. It is not difficult to show that any map preserving transition probability is a restriction of a Jordan star homomorphism. Very interesting to show that Jordan star isomorphism in terms of unitary and anti-unitary maps. We have some results, and first results illustrate situation in 2x2 matrices. You can see these results. And algebra 2x2 matrices describe a two-level quantum system. Its state space has a natural geometric interpretation. Let us identify each state with a positive matrix of trace 1. Every density matrix T can be represented by a vector in the three-dimensional union in the following way. And having a unitary anti-unitary map where on a Hilbert space H we can define map at V. And we have two results. The foregoing results on a structure of Jordan star isomorphism established Wigner theorem both for finite or infinite dimensional Hilbert space. This is a finite version, and infinite version for quantum system. Let phi it is infinite maps from one as a projection where H is a separable infinite dimensional Hilbert space, be a map preserving transition probability that phi satisfied with relation. When there is a linear or antilinear isometric map V acting on H, such that phi of P is V, P V starful or ortho projection. And there is some logical version of Wigner theorem, and in this case, symmetries of orthogonality structure are the same as the transition probability, except for the algebra by 2x matrices. Let H be a Hilbert space with dimensional H more equal 3. Let phi be an orthoisomorphism on a set of projection. When there is a unitary or an anti-unitary operator U acting on H, such that phi of P is U, P U star for all orthoprojection. Next line, it is Dye theorem. Classical Dye theorem for Neumann algebras. This theorem, let M and N be for Neumann algebras where M has no type 1, 2 direct summand. When any orthoisomorphism phi from a set of projection of M to set of projection of N extend to a Jordan star isomorphism of M to N. What is there are questions for AV star algebra. One of major problem in theory of AV star algebras is generalization Gleason theorem holds also for AV star algebra without type 1, 2. Since a positive answer resolved many other difficult problems in the theory of operator algebras, the problem is expected to be difficult. The idea of providing Dye theorem for AV star algebras must be different from the case of Neumann algebras. And fortunately, we can combine local Gleason theorem and matrix approach imitated John von Neumann and Dye and developed future by Heinen and Reins. And I think it is this result. And we have with interesting result with generalized Gleason theorem and main theorem on this line. It is a theorem Dye-Hamhalter. Let A be a AV star algebra without type 1, 2 direct summand and B be a AV star algebra. And let phi be a map preserving all suprema and orthocomplements, and there is some relation, and in this case phi extends to a Jordan star homomorphism from A to B. And next line, it is area of abelian subalgebras. Let A be a unital C-star algebra by the symbol C of A. We shall denote the structure of all abelian C-star subalgebras on A containing the unit of A. When we've said theoretic conclusion, C of A become the posets with the elements and infimum in these posets are given by the set theoretic intersection of subalgebras. On the other hand, supremum of two elements if exists in these sets if and only if two elements mutually commute. We shall denote C0 of A, the posets of all unital abelian C-star subalgebras, not necessarily containing the unit of A. And let P be a subset of C0 of A, Q is subset of C0 of B. We map phi from P to Q is said to be implemented by map phi from A to B if phi of C when this equal is true. And C of A is a sister invariant in category of unital sister algebras. It is not a complete invariant in general, as the opposite algebra has precisely the same poset C of A. Well, A and opposite maybe not isomorphic as sister algebras, as celebrate result of type 3 factors due by Cohn's show. And poset C of A is not a complete invariant in category sister algebras. It is C of A is a complete invariant in the category of abelian unital sister algebras. We have shown what more is true by establishing one-to-one correspondence between star isomorphic of abelian sister algebras and order isomorphism of posets of unital abelian sister algebras. And we have we will have next theorem. Let A and B abelian unital sister algebras. Let phi be an order isomorphism. And when there is a star isomorphism psi from A to B, such that phi of C is psi C for all elements of C of A. If dimensional A are more 2, when psi is uniquely determined by phi. In case of abelian algebras, the poset C of A is a complete lattice. It is not true in non-commutative case, where supremum of elements do not exist in general. One cannot hope for theorem to be built on this wider context. Based on the fact that Jordan C-star isomorphism preserves commutativity, it can be shown what a Jordan star isomorphism between a unital C-star algebra A and B implements an order isomorphism phi. Since there are many Jordan star isomorphism, what are not star isomorphism, we can see that in the in the preview observation, not all other isomorphism of posets of abelian subalgebras are induced by star isomorphism. Even more is true, one can realize what every quasi-Jordan star isomorphism implements order isomorphism. And first proposition, if not difficult to see, that a unital quasi-Jordan star isomorphism have a restriction to order isomorphism, whereas natural equations the converse hold as well, and answer is the positive if and B unital sister algebras, when for any other isomorphism phi, whereas unital quasi-Jordan star isomorphism psi from A to B, such that this equal is true. And if A is not isomorphism whenever C2 or 2 by 2 matrices, when psi is uniquely determined by phi. And for sets of all subalgebras, it is difficult to see results, but we have with theorem. Let A be a unital sister algebras isomorphic C plus 2 or by 2 by matrices, and in this case isomorphism phi implemented by quasi-Jordan star isomorphism with equation. And for non algebra, we have two, this in Russian, two interesting theorem in this style. Thank you very much.